Welcome back to ASP.NET Core Unit Testing video series. Today is the second session, and today we are going to develop a real-time ASP.NET Core project for unit testing. In our previous session, we have discussed the basic concept of unit testing. We have created a simple calculator service class. We have created this class with some simple add, multiply, sum, and divide operation. And we have also seen right how to write unit test code to test these services, right? But in real-time application, whenever you are going to work, you will not find this kind of a simple services without any kind of a dependencies. So today, what we'll discuss how you are going to develop real-time application with layered architecture, what is the role and responsibility of each layer, and how you can unit test each layer effectively. So let us proceed and understand these things in detail. See, a well-organized project is the backbone of a scalable and maintainable application. So whenever you are developing any ASP.NET Core project, particularly Web API, it means we should clearly separate the responsibilities. We should clearly separate the responsibility to different layers. So what are the layers commonly used in web applications? So mainly we are going to deal with the presentation layer. We are going to deal with the service layer, and we are going to deal with the data access layer. So in our ASP.NET Core MVC, in our ASP.NET Core Web API application or MVC application, the controller is nothing but your presentation layer, which will handle the incoming HTTP request and the responses. This controller is also going to manage the call to the business logic layer. So this services is nothing but going to be our business logic layer, which is going to contain the core application logic, core business logic, core validation logic. The repositories are nothing but you can consider this is going to be the data access layer. So data access layer means you have to write the data access logic within the repositories. So whenever we are going to deal, specifically whenever we are dealing with the ASP.NET Core Web API, we need to use DTOs, effectively transfer the data between the client and the server. So whatever the data you want to exchange between the client and the server, those data needs to be right stored inside the DTA. And this model and entities, these are nothing but your domain entities, or you can say database entities for which you want to create a database table. So why we need separation of concerns, or why we should not put everything inside the controller? Why we need to create a controller, services, and repositories? See, adding new features without breaking existing one. So as you know, whenever we are developing any real-time application, changes are permanent. As you progress, you might need to change some of the existing functionality. You might need to enhance the functionality. You might need to add new functionality. So whenever we are adding new feature, the existing features should not have any impact. Writing robust and integration unit test. See, if you are creating the application in a layered based, then unit testing is very easy. You can easily unit test controller logic. You can easily unit test service logic. You can easily unit test, right? What I can say, repository logic, refactoring and scaling. So what do you mean by refactoring? For example, today you develop one application and you want to enhance the performance of that application, then how you can do this? So you have to modify the existing code. But when you are modifying the existing code, what you need to do? So it should modify the existing code to improve the performance, but at the same time, the existing functionality, what is your main business logic, what is your goal, right? What, for what purpose you are creating that function, that should not have any interval, right? That should not really disturb. So for this purpose, separation is very, very important. So let us understand, this concept by taking one real-time order management application by creating a different layer, and then we'll see how we can unit test each layer. Now, if you look at this diagram, right, this is the diagram of a order management API. As you can see within the API, we are going to deal with the controller. Controller will provide the endpoint, which is going to be consumed by the client for creating an order, for fetching the order details. Services, the controller will consume the service method to perform the operations. And these server operations are going to be validating the order amount, validating the order discount, whether the stock is available or not. Right, all these things we need to write here. Repository is nothing but the data access layer you can consider. using entity framework or using ADO.NET, right? Whatever data accession logic you are implementing or technology you are using which you can perform the CRUD operation over the database. And DTOs are nothing but these are the data transfer object which will be used by the client and the server to exchange the data. Now, so this is our WebAPI project. Now, what is our objective? Our objective, we need to test the controller logic. We need to unit test the service logic. We need to unit test the repository logics. For this purpose, what you need to do, you need to write a unit test code. So we can write some method to test controller logic. We can write some method to test service logic. We can also write some unit test method to test the repository logic. So what is the challenging thing here? The challenging thing is how? See, for example, if I'm going to test the controller is going to consume the services. The service is going to consume the repository is going to deal with the database. So in this case, whenever we are testing the controller logic, then I should only test the controller logic, not the service logic, not the repository logic. Similarly, whenever I'm testing the service logic, then it should only I mean, it should validate the service logic, not the repository logic. Then how we can achieve this? Now, in that case, whenever I'm writing some unit test for the controller, I need to create a mock object of the service. So instead of dealing with the actual service implementation, what we need to do, we need to create a mock service object. Similarly, whenever I'm writing a unit test for the service, I need to create a mock repository instead of using the original repository. So this mock object or mock repositories are very, very important whenever we are dealing with unit testing. Why? Let's see, in this case, for example, you are dealing with some database file system or some external API. So do you think that the database is always going to be in active mode? It might be possible that database is down. It might be possible the third-party services, what you are consuming, they might be down. So in that case, because of the external dependencies, my unit test should not be failed. That is one of the important reasons. Second, so unit test should run fast, very, very fast, right? For example, if I'm consuming some external services or database call, they're taking more time. Then we shouldn't wait that much of time. So here, the issue is not with our logic, issue is with our external dependencies. And this controller or services, they should not have any they should not test the external logic or external dependencies. That is the reason why this mock object are going to be created, which are going to be very fast, and we should use mock whenever we are writing unit test code. So now let us proceed and see how we can do this thing. So for this purpose, what I'm going to do, I'm going to create two projects. One project is for the web API, where we'll write all our controller, business, repository, DTO, model classes, DB context, all these things we are going to write. And we are also going to create one unit test project using xUnit framework, where we'll write unit test code for testing each individual component. For example, controller action method, repository method, service method. So all these methods we need to unit test, and for that purpose, we are going to create a separate unit test project. Now you might have one question, sir, why you are creating two different projects? Yes, because of the maintainability. Because I don't want to publish my code to the production server. That is the reason why I'm putting this thing. Okay. So let us proceed and create the project step by step fast. So first of all, what I'm going to do, I'm going to create one empty project solution, and within that empty project solution, I'm going to create my project. So one ASP.NET Core Web API project and another what I can say text project. So click on this blank solution, then click on the next button. Provide the solution name as product catalog, then click on the create button. So this should create an empty project solution in Visual Studio. So once you create the empty project solution, then what I need to do, I need to create two projects. One ASP.NET Core Web API project and another text project. So what should be the name of your web API project? You can decide. For my project, right? In this example, I'm going to provide product catalog.api as the ASP.NET Core Web API project name. Let me first close this calculator service project, what we created in our last session. So let me add a new project. So how you are going to add a new project to an empty solution? Right click, add new project. So here what you need to do, you need to select what type of a project you want to develop. I'm interested for web API. So select this ASP.NET Core Web API, click on the next button, provide the project name. By default, that location will be taken, whatever the location where you created your solution. Then click on the next button. I'm using .NET 8 and then click on the create button. So this should create my ASP.NET Core Web API project. Now, one more thing I need to do. So that default controller, whatever is created, that I will delete. That default forecast model class, that also I'm going to delete, right? So these are the two things that what I need to do. Again, as I'm going to deal with SQL Server database and I'm going to use Entity Framework Core, so I need to install these two packages in my Web API project. So go to the Tools, Package Manager console and install these two packages. So one package is the data provider for SQL Server and the second one, it is the migration package. I mean, to sync your database with the models, we need to generate the migration file and update the migration file. For this purpose, the second package is required. So with this, your project should looks like this, and you can see this is the same now. So once you have created this one, next what we need to do, the same solution, we need to add one unit text project. So as we are going to use xUnit, right? So we are going to use xUnit for our test project. So again, we need to do the same thing, right? So what we need to do, again, right click on your solution, add new project. So once you come to this one, another option is there. Here you can search for xUnit. So you can select from here. You can also select from here. So here you can see xUnit text project. So which is targeting the C# project, C# language. Other options are there, VP, but we are interested with this C#. Then click on the next button, provide the project name as product catalog text. So this text explicitly specify that this is going to be a text project. Then click on the create button. So here you can see API explicitly specifying this is the web API and this is our test. So here we are having some dependency issues. So what you need to do, right click and right click here and update. So we need to update the packages. So basically whatever packages updation is required, click on this update and this should update this package and we should this error message should have been gone, right? Apply and accept. So that's it. So our two projects are now ready. So once the project is ready, right, then what we need to do, we need to add a reference to this web API project from our text project. So how you can do this? Now right click on your dependency, right click on the dependency folder of your text project and select this add project reference and select this one. So why we are adding a reference? Because in the web API project, we are going to have controller classes, service classes, and repository classes. And those classes instance we need to create here and we need to call those methods. So for that references, right, we need to have a reference to that controller services and repository. We should refer to that project here. So once this is done, right, next what we need to do, we need to start developing our web API project. So as we are going to implement the web API for order management, so let us proceed and create the models first. Then we'll create the DTOs, then we'll create the DP context, then we'll create the repository classes, then we'll create the service classes, and then we'll create the controller classes step by step. And this project, right, what I'm going to do, I'm going to follow the industry best practices. Industry best practices means what? I'm not going to put everything inside a single folder rather than as per the recommendation by Microsoft. So we will create a different folder for different functionality. So first of all, we need to create a folder called model where we will create all our models or entities, and this needs to be done within your web API project. So add a new folder called model, and inside this models folder, whatever classes or whatever database table you want to create, for each database table you need to create a entity, or you can say you need to create one model. So as I am going to deal with order management, so for order management, basically for order management, you need the customer, you need the order table, you need the order item table, you need the product table. So whichever product is going to purchase by the customer, that product information we need, who purchased the rate, who placed the order, that customer information we need, and we need to create two more table. One is for order, storing the order information, that is order amount, order date, who is the customer, and one table for order item. As part of a single order, you can have multiple items. So for storing those multiple items, we will create another table, that is order item. So let us proceed and create these tables first. So let me first create a model of the product. So product table. So whatever the data required, so let me go ahead and create this one. So this is going to be my product table. And here you can see this is going to my product table where we are having ID, product ID, which is going to be unique identity, product name, price, stock, description, and the list of order items, right? So this product can be used as a reference in the order item table. So let me go ahead and create the next one. Next is going to be customer. Here you are getting this order item as error because we have not yet created an order item entity. So next one is the customer entity. So let me go ahead and create the customer. So the customer information, whatever we want to store in the database, that what we are going to store, that is customer ID name, email, and the order. So one customer can have multiple order. So that is the reason why this list of order property is going to be there. Now, next what we need to do, we need to create the order entity. So order entity is going to contain the order information. Whenever a customer place an order, those order details, right? That order information we need to store inside the orders table. So ID, whoever the customer placed the order, and this will be created as a foreign key. So that navigation property will specify here what is the order date, what is the base amount, and this is going to be discount amount if any applied, and after minusing or after deducting the discount amount from the base amount, what will be the total amount, and as part of a single order, how many order items are there, that what we need to write, we should have a reference. So next what I need to do, we need to create the order item entity. So this is going to contain the line item of a order, right? How many items you place as part of the order, one item, two item, three item, all this information for each item, one new entry in the database table. So whichever order ID, what is the product ID, what is the quantity you purchase, what is the unit price at the time of a purchase, and what is the line total, which is nothing but multiplication of a quantity into unit price. Now with these changes, you should not have any compilation error anymore, right? So this is going to be all our DTOs. Sorry, model. So next what we need to do, we need to create the DTOs. DTOs means data transfer object. So we are not going to expose these entities to the client. Why? Because these contents might be some unnecessary data, some sensitive data, which is not required by the client, but it is required for us to manage the business logic. So that is the reason why we should not expose our entities to the client. Rather than what we need to do, we need to create lightweight entities. So these DTOs you can consider lightweight entities, and these entities are going to contain the data which we want to expose to the client, or which data we want to take from the client. So for these four entities, let us proceed and create DTO. So one DTO is for order item. So you can see this is my order item entity. So I'm going to create one DTO to represent this order item. But this order item, it is going to be lightweight. Lightweight means you can see here I'm having multiple properties like ID, order ID, product ID. So this reference property, quantity, unit ID, line total. But here you can see while I'm creating one order, what information I need. I only need the product ID and quantity. So based on the product ID, I can paste the unit price from the database. I can calculate the total amount. So while you are creating, you only need these two information. And this order item DTO will be used, right? Order item DTO will be used as part of the order created DTO. So while creating the order, along with the customer ID, the user needs to specify the list of order items. So this is going to be customer ID, and this is going to be my list of order items. So this order item DTO will be used to create the order. Next, what I need to do now, once the order is created, the user might be accessed the order details, right? What is the order information? So for that purpose, for the response purpose, we are also going to create a two DTO, order item response DTO. So this DTO is going to contain the details which we want to expose to the client. For example, order item ID, product ID, what is the product name, description, quantity, unit price, and a line item. Similarly, this will be used as part of our order response DTO. So for one order, right, you can have a multiple order items. So that is what we are going to create here. So this is going to be my order response DTO. So once while creating the order, the user will pass this order create DTO, and while we are retrieving the order information, we will use this DTO. So now next, what we need to do, we need to create the DP context. As we are going to use entity framework core code first approach. So let us proceed and add a folder first with the name data. And within data folder, let me create my DP context objects. So this DP context object will have DP set properties for all the four models along with the initial domain data. That is what we require from the operation. So you can see this is my DB context class, application DB context. Here on within the on model creating method, I'm adding few products. That is three products I have added and the two customer I have added. Coming to this order and order items, that what we will write it. Create manual in the sense using our API we will see how to create order and how to paste the order details. So now you can see we have applied these entities, right, with the division properties in the database. It will create four tables. One is for product, customer, orders, and order items. So I'm not giving focus on this part. Why? Because you already are about entity framework code. So now what I need to do, I need to create the repositories. Repositories are nothing but the layer, or you can say it is the data access layer. So how you are going to perform the database operation with the database, that logic you have to write here. Whether you are going to use entity framework core, whether you are using Dapper, whether you are using ADO.NET core, and whatever. So those logic you have written here. So this is the layer which is going to directly communicate with the database. So let me first create a folder uh, called repository at the project root directory. And guys, remember, as whenever you are going to implement unit testing, it is mandatory to implement the functionality based on the interface. So first of all, you need to create an interface, define the signature, create the implementer class, provide the implementation. Why? Because if we are going with the interface based approach, then it is very easy for us to implement the mock repository, mock service class. So for that, creating the mock object interface is mandatory. So what I'm going to do, I'm going to create my repository interfaces and the implementation classes within this same folder, right? So let me go ahead. First of all, create the order repository, right? For order repository, whatever functionality you need to define, that what you need to define. Here you can see get ID, add order, get by ID, add order, and this step changes async method. So this is my order repository. If you want, you can enhance the right. You can increase the number of methods which are related to order management. Similarly, my product repository interface is going to be there. So to manage the product data, whatever functionality is required, right? So those functionality we need to declare here. So the implementation will be in the implementation classes, but here only the definition. So get by ID, add product, and the step changes as in. Similarly, I need to create the customer repository for customer management. So here I'm going to create a single class file. Sorry, I'm going to create this class file with a single method, and that method is going to retrieve the customer by ID. So you can also enhance these interfaces by including the necessary or the related interface, right, related methods. So now once the interface we define, then what we need to do, we need to provide the implementation classes. So first of all, create a class file with the name order repository. So this class file will inherit or from this iOrder repository and provide implementation to all these three interface methods. So let us proceed and implement this. And for this purpose, I'm going to use right entity framework core. So first of all, I need to inject my DB context. So using this DB context, I can write the code. So get by ID method means using the DB context from the orders table based on the order ID, I'm fetching the data. While fetching the data, also I'm lazily loading, right? Eagerly. So this include method means in the implement eager loading. So automatically loading the order items, related product information, related customer details, right? So this is my add async method, which is going to add a new order. And when you add this order, and when this will mark the entity state as added, and when you call this changes method, these changes will be made permanent into the database. So this is going to be my order repository. Next, what I need to do, I need to create my product repository. So let me go ahead and create a class file with the name product repository. So this product repository is going to implement the same set of functionality which we defined here. So get by ID, add async, and set changes async. So this is also injecting, we are also injecting the application DB context, getting the ID, product details by ID, adding a new product and calling the set changes so that this product will be added to the database. Similarly, customer repository, this class going to have one method which is going to retrieve the customer details by ID. So let me go ahead and implement this one. So this is going to be my class file, injecting the DB context instance and using that DB context instance based on the right customer ID, we are fetching the customer details. Next, what I'm going to do, I'm going to create a custom exception. See, whenever we are implementing unit testing means testing all the scenarios. All the scenarios means positive scenarios, negative scenarios, exception scenarios, and all these things we need to test. So in this example, right, in this application, what we are going to discuss, we are going to discuss the not found scenario. Not found means product not found, order not found, customer not found. And whenever the product, order, and customer not found, we are going to simulate a scenario by throwing one exception. So for that purpose, we are going to create a custom exception class. So first of all, create a folder called exception, and inside this exception folder, we need to create all our custom exception classes. So now we are going to create one class called not found exception. And this class is going to throw, right, not found exception. Whatever the message you want to write it through, that what you can provide a constructor. So this is going to my write custom exception class. Next. Next, this is the repository layer completed, right? Which is going to deal with the database. Does the controller directly communicate with the repository layer? No. Why? Because repository layer only know how to perform the database CRUD operation. Repository layer doesn't have any idea about the business logic, about the validation logic. Then you have two options. Either you can write the business logic, validation logic directly within the controller class. Otherwise, you can go with a service layer. So what is the problem if I'm writing these things within the controller class? See, controller main objective is not to manage the business logic. Controller main objective to handle the request and return the response. So for better understanding, so for better productivity, better clarity, better maintainability, what you need to do, you need to introduce the repository layer, which is going to sit between the controller layer as well as between the controller and the repository layer. So what we are going to do is we are going to create the services, and this services is going to manage the business logic or the core logic of our application. Again, what we need to do, we need to create a folder called services, and within this services folder, we are going to create all our services. For time being, as we are developing this for order management, I'm going to create a single order service. Otherwise, right, rest of the things you can manage yourself, right? Right, meaning what? Order manage, customer management, product management, that's what you can handle yourself. But for now, what we are going to do, we are going to create the order service for creating the order, writing all the business logic, and fetching the order details. So again, what I need to do, I need to go with the interface-based approach so that I can write the mock, so that I can create the mock object. So first of all, create one interface iOrder service, and within this iOrder service, go ahead and implement this, provide this two method signature, create order, which is taking the order created DTO, which we have already created, order created DTO. This order created DTO, it will take, which will contain the customer ID and the list of order items. And based on the order ID, it is also going to return the order response DTO, which we have already created, right? So once the order service is created, next what we need to do, we need to provide it implementation class. So go ahead and create a class file. So this is going to my order service, and this class is going to provide implementation of a two method. So which two method? Those two method which defined in the high order service interface. So this is the class where we have written all our business logic. First of all, perform the order placed operation. What we need? We need the customer information, whether the customer is valid or not. We need the product information, whether the product exists or not, what is the quantity available, and definitely we are going to create two entities, one in the order table and some entities, right? One in the order table, one or more entity into the order items table. So that is the reason why we expect these three objects, right? The order repository going to deal with the order creation, I mean creating order and order item. Product repository going to fetch the product details and update the product stock once the order is placed, and the customer repository verify whether the customer who is placing the order, whether that customer is a valid customer or not. So for that purpose, we are going to deal with this customer repository. So let us proceed and understand the logic. So create an order. So we are getting this order created DTO, which contains the customer ID. First and foremost thing, customer is exist or not. That validation we need to check. If the customer doesn't exist, we need to return this not found exception. So this not found exception means this is the customer exception what we created. And whatever the error message we provided here, that error message will be thrown to the right now. So once this is done, if the customer is exist, then what you need to do, this order created DTO, you can see it is taking one items, order item DTO. So means what? Means whenever you are placing one order, you have to provide at least one item. If items is not, means you are trying to create one order without providing any product information. So that is what, in that case, we need to throw this argument exception. If the customer is valid and you have provided some order items, then we can proceed with the order creation. First of all, create one order object, right, of this order entity, specify the what is the customer ID, order date, order items. Here we are initializing this order items with an empty collection. Why? Because the user provided some product ID 1, some product ID 10. Whether this product ID 1 and 10 exist in the database or not, that what we need to validate. After validation, then only we can initialize with the original data. So how we can do this validation? Now look through all the order items. So once you look through order items, fetch the product information from the database, and for that purpose, I'm using product repository. So once the product is available, that is fine. If not available, throw not found exception. If product is available, but the quantity, whatever the item, that quantity, if that is a negative or zero, then we should throw this one, right? That means product is out of stock. Similarly, whatever the stock you want to purchase for that particular product and whatever available stock, that available stock should be greater than the stock you want to purchase. Otherwise, you have to throw this invalid operation, not enough stock. So why I'm using now, I'm here specifying different exception so that I can text this scenario using my unit test. Right? If all these validations are fine, product available, quantity is greater than zero, whatever the item quantity, right? I mean, whatever the quantity you are going to purchase that is less than the available quantity, then in that case, what we need to do, we need to create the line item. So line item means what is the product price and how many quantity you want to purchase, that is going to be my total amount, right, for that particular product. Then what you need to do, you need to make an entry to this order items entity. So here you need to set what is the product ID, what is the quantity, unit price, and the line total. And once this is done, then we are having, we need to store the base amount, discount, and total amount. So whatever the line total here, that we need to store inside this base amount variable. So that at the end, this base amount is going to total, it gives also total amount of the order. And this is my base amount. And once the order is placed, then what we need to do? We need to deduct the quantity. So currently this product having the quantity stock, and this stock we need to minus from, right? So this is going to be the product stock, right? So product stock, and this stock should right, deduct this one, right? That is what I'm doing here. So whatever the product available stock, that what I'm deducting from the item quantity. So then once this will be execute for all the line items, then whatever the base amount we already calculated here, that what we are going to store in the order base amount, right? So once the base amount is done, And then what we need to do, we need to calculate the discount. So how to calculate the discount? By calling this calculate discount method. So if the base amount is greater than 5,000, then we are applying a discount of 5%. So that is the some logic we have written here. You can manage this logic right as per your business requirement. So whatever the discount we get, the base amount minus discount is going to be my total amount. So we have calculated the base amount, we have calculated the discount amount. Discount amount will be zero if the amount to rate base amount is 5,000, less than 5,000. If it is greater than 5,000, 5% will be the discount. And then we are calculating the total amount. Then finally, what we need to do, we need to add the order into my order repository, call the product repository save changes method so that whatever the updation we have done here, that will be updated in the products table and save changes on the order repository so that this order and the order items are going to be added. And then we have the order and we have the customer. So we have to map this data to write the order response detail, which will return to the client. So order ID, customer name, email. See this order information, customer information. We are rate fetching and storing all this information in my order response detail, which will return to the client. So why we are creating this as a separate rate private method? Because this method I'm going to use at multiple places. So while I'm creating the order, after the order creation, this method I'm returning. Again, if you look at this get order by IT async method, it is using the ID to retrieve the order. So using the order repository, it will retrieve the order information. If the order is null, so we are returning null. If the order is not null, then we are retrieving this information from the database, right? And then we are mapping. So as you can see, this order get order by ID method, we are including the customer details. So as we are including the customer details, so this statement is not required. Why? Because we are right, because we are already including the customer information. So you can simplify this. Clear? So this is going to be my service class. So the next thing what we need to do, we need to create my order controller, where we need to create the order controller within the controllers folder. So go ahead and create add a controller. You can create as a class file and then you can convert that class to a controller. Otherwise, you can create that API empty controller directly. So here I'm creating a class and I'm converting that class into a controller class. So here you can see I'm injecting the order service. So this I order service I'm injecting, and then using this service what I'm doing, I'm taking this order create DTO as a input object, validating whether that model state is valid. If valid, then I'm calling this a create order method by passing this DTO, which will create the order. And if this order is created successfully, that order we are returning to the client. If I'm getting some not found exception, argument exception, invalid operation exception, then accordingly we are returning some exception response to the client. And this is my get order method. I'm fetching this data. If I'm getting the order that is found, uh, then we'll return okay with that order. Otherwise, we are going to return not found error response. So this is fine. So we have implemented. Now what we need to do, we need to configure our connection string. So you can see within the app settings.json file, we'll configure our connection string. So this connection string, I'm specifying the database name, I'm specifying my server details, and here I'm using trusted connection to means Windows authentication, right? So this will create a database orders DB in my SQL Server database. Currently, you can see there is no orders DB. So let me refresh so that you can see. So currently there is no orders DB database. So once this is done, then what we need to do? We need to modify the program class. So what are the things we need to do? Within the program class, we need to configure DB context to use SQL Server connection string. We need to register our repositories and services, whatever we have created. We need to write disable the common case naming convention, and we need to enable Swagger for testing and documentations, right? So let us do this thing within our program class. So go to the program class and replace this code, and let me show you. So this is nothing but registering the services and disabling the camel case so that whatever the property name we defined within the DTO, they will be used as it is. This is going to be my registering the DB context to use SQL Server data provided and the connection string I'm getting from the app settings.json file. So this is nothing but enabling the Swagger API documentations. This is nothing but registering my repository classes and the service classes. So with these changes, next what I need to do, I need to generate the migration file and apply the migration file. So to do this thing, what we need to do, I need to create my package manager console. Clean this one. First of all, select the project. So on which project you want to generate the migration file? I want to generate the migration file in the API project. That's what you need to select here. Then write the command R migration. Any name you can give. MIG1 I'm giving. And once this migration file will generate the class file with the required changes, modification, and then we need to apply that changes so that the database is going to be created, right? So next, what I need to do, we need to write the update database command, which will generate the database with our models, which we configure in the DB context class. So that's it. So now refresh this one. You should see the orders table, and in the orders database, right? You will see customers, so whatever the initial dummy data we provided, and the products, right? Whatever the initial product we have provided, those informations are there. So with these changes now, before writing a unit testing, right? So let us try to understand, right, whether these APIs are working as expected or not, right? So what I'm going to do, I'm going to test this one. So first of all, you need to select this text project. Otherwise, you can also select from here. So currently, you can see API project is selected, and you can also mark this project as a startup project, which is already marked. So now click on this button, which will run your web API project. Okay. Now I want to test this functionality. So for testing, what is the data required? Customer ID, product ID, and the quantity. Let me test this one with some dummy data. So I'm providing some valid information this time. Customer ID 1, which is exist. You can see customer ID 1 is exist. Product ID 1, 2, 3 are exist. So here I'm providing product ID 1, quantity 2, product ID 2, quantity 3. For 1 and 2, I'm providing quantity 2 and 3, which is less than the stock available in the database. So this is valid data. Click on the execute button. So once you click on the execute button, you are getting the response as expected, right? So next, what I'm going to do, I'm going to show you how you can test this one. So get order by ID, another endpoint, provide the order ID, which we generated here. What is the order ID? 1. So click on this execute button. So this will also give you the same response. Now what I'm going to do is I'm going to test one negative scenario. So where I'm going to provide some wrong information. So let us proceed and see this thing. So first of all, I'm providing customer ID 0, which is not available. Product ID, which is invalid. Quantity is also invalid. So click on this one. See what error I'm getting. Quantity must be at least 1. So what I'm doing here, I'm passing this one. So now if you see customer ID with 0 not found. So I'm passing customer ID 1. So this time it should give me this 999 as a invalid product ID. Product with ID not found. That means it is working as expected. So with these changes, we have right set up our ASP.NET Core Web API project. It's next. Next, we need to unit test. We need to unit test each component. Each component in the sense we need to write a unit test for testing the controller class methods. We need to write a unit test for testing service class method. We need to write a unit test for testing repository class method. And one by one, right, we will discuss this thing. So the next session, what I'm going to do is I'm going to show you how effectively you can write a unit test for testing the service class method. Then I will show you how to write a unit test for testing the controller class method. Similarly for repository class method. Then I'm going to discuss also how you can implement a test-driven development. And finally, I'm going to conclude with the integration testing. So that's it for today. If you like this video, then please subscribe and don't forget place the bell icon. Thank you. Thank you for watching this video.